Mining and data warehousing. So today's session we are going to take one simple of example with regard to APROI principle. Now when I say simplest of example, this example is the what do you call the basics with regard to understanding of APROI principle. Now we are going to look into APROI principle from many perspectives. When I say many perspectives, we are going to look at from a textbook perspective, from an exam perspective, and from also from the understanding perspective. So we are going to start from an understanding perspective. Okay, because this is something which I want you to become very good in, because it will really help you in 7th. The only thing that you can sort of take out right from data mining into the next semester is the understanding of things that are becoming very important in 7th. Okay, otherwise it's just a theory part where you sort of write it in exam, you get the marks. Okay, there's no point in it. Your internal marks, everything is it's all finalized, but it's up to the class teacher. Okay, I've sent her. She told not to send to the group and all. When she says to be able to send to the group, I'll be sending it. Okay, I don't know what is the problem. Maybe some fees related issue, something like that. Okay, that I think you need to talk with her. Anyway, if she says no problem to send it in the group, I'll be sending it. Okay, not a problem. Okay, yeah. Before we go in there, so what is our thing today? Okay, we are going to take one simplest of examples. So I've taken right from the net itself. Okay, a place where you generally study basics of certain things. I've taken right from there itself to figure out what it is. Okay, APROI principle and all. Before going there, so just want to say, what are the things that we have learned and where do we end up in APROI principle and all. Okay, we started learning what is known as association analysis. Very important aspect of figuring out what is the association between items. We call it as association analysis. In association analysis, you clearly know we come across an item called frequently brought items or frequent items. We came across this because very simplest of example, right? The milk, bread, butter example. We took that and we came across a term called frequent items. And when we're analyzing frequent items, we got into a perspective where this, analyzing these frequent items was too tough. Okay, was too tough because as the input sort of increases, the brute force method or a manual method becomes very tough. So what we did was we used a technique called pruning. Okay, now what is the thing with regard to pruning? Pruning is we are going to take out those items which are not frequent. Okay, fine, that's all fine. Okay, we understood that in a previous example, pruning technique and all fine with regard to it. But there is one more thing that we sort of analyzed, we came across. There were two strategies that became very important there. Two strategies of what can be done with regard to lessening or decreasing the number of frequent items. The first thing was with regard to what comparisons between, you take out the entire the number itself, frequent items itself. That came under a concept called as APROI principle. The next one is with regard to you reduce the number of comparisons itself. The number of comparisons. There in APROI principle, we are reducing the number of items. Be careful with regard to the values I'm talking about. Here we are reducing items. Here we are reducing the number of comparisons. So now we are studying about this one, which is nothing but the first technique, which is known as APROI principle. Okay, this is something that you should always put through and all. Okay, any subject which you are learning, you need to sum up like this. Okay, just by looking at it, you should be able to sum up everything like this. Okay, so this from here itself we are going to take it up. Of course, we are going to look into APROI principle, APROI algorithm from a very simplest of example. Probably in the tomorrow's class, we are going to look into a major example for it. We are going to look into two examples probably. Because, again, I'm telling you the same thing. I want you to become perfect with regard to it. Okay, so that's what we are going to look for. Today's example will be a very simple example. So let's look into it. Okay, so I've taken, this is what we can see right here. Okay, I've taken 3 transactions right here. I hope it's all visible. Yeah, it's visible. So we have taken what is known as, once again, I'll make it even more bigger. Yeah. So once now this is all fine. Yeah. Now, what is the thing that we are sort of looking of? We have taken 3 transactions here with IDs. IDs can be anything. Okay, we generally take 1, 2, 3, 10, 20, 30 like that. Because we don't want to know what is the transaction IDs and all. Generally, when you do a transaction, people from the retail store, they'll be knowing it. It will be more like a alphanumeric characters. That transaction on a particular date and a particular time. What was that number? No, the row or what you call the billing counter. Based on that billing counter, the transaction IDs, everything will be varying on all. Here we are going, taking for an example, you're taking 10, 20, 30 on all. Okay. So let's take that. Okay. We have taken the transaction ID as 10, 20, 30, and the items are ABCD, BCD, and AB. So basically there are 4 items and 3 transactions. Now we are going to take the minimum support as 2. Okay, please keep this in mind. This minimum support can be any value which you are supposed to take. It can be 2, it can be 3. People will be deciding it based on the number of items that is sold. Here we're taking it as with regard to 2. As you can see very clearly, the minimum support is with regard to it as 2. Okay. So we got 3 transactions. After this, what is the next step? We do the first important step where we are going to write all the combinations that are possible. Okay. So if I write all the combinations that are possible, the first combination is taking all individually. A, B, C, D. See? I've taken that A, B, C, D. How many times they are repeating? A is coming in 1, 2 places. B is coming in 1, 2, 3. All the 3 places. So I've taken 3. C 1, 2. So only 2. So I've written 2. Then D. How many places? 1, 2. Only 2. So I've written 2. Okay. What about E? So there's E. Sorry, there's 5 items, not 4. Okay. Now there's E also. So what we have taken? E again 2. See, we have taken the first thing, which is to figure out what all individual thing individually. Okay, individually we have taken, and there also the support. We have taken the minimum support to be 2. Now we got all these values 2, 3, 2, 2, 2. Minimum support is 2. So now I think looking at this, we can say this single support item support table, single item support table, all of them have minimum support, which is either equal or more than that. It's either 2 or more than 2. Not a problem. Okay, not a problem. So what is the next strategy? The next strategy is to make sure that we take in combinations again. But what combinations? We take it in the double combination. How many will be there? So there are 5. When you take 2 at a time, there will be 10, right? 5C2 10. Remember DMS combinations. Okay, 5C2 is nothing but equal to 10. So when we take combinations A and B, how many places we are getting A and B? A B here, A B here, so 2. Okay, then we take A and C, A C here, and that's all. A C is only 1. A D, how many places? A and D and A and D, only 1. A and E, A and E, how many places? Only 1 place here. You got here. See this A and E, only these places. So we need to look into the support of double values, or when you take 2 things at a time. So how many like that will be there? You got AB, AC, AD, AE. Then BC, BD, B. Then CD, C. Then DE. So total you get 10. Okay, total you get that's what I've clearly written here. Have I done anything new? No. So we take all the 10 combinations that are possible. Okay, you see this? 2, 3, 4, 5, 6, 7, 8, 9, 10. This, knowing how many combinations will come is a very important thing. That is where the knowledge of DMS, where you studied somewhere in 4th sem, is coming in here. Okay, this is called applying the knowledge of what you studied way back in the previous semesters in here. Okay, see now it's only 5, you take only 2 at a time, 10. What if it is more? Okay, what if the number is very, very more, and where you're writing an algorithm to figure out what is the number of combinations that are possible? What if there are around 47 items, and you need to take maybe around 12 at a time? Then is it manually able to do? No, very tough. Unless and until you will be able to know the combinations aspect of it, 47 C12, then you know how to be able to do that. In combinations also you studied various things, right? Combinations with repetitions, without repetitions. Never forget. Okay? Never forget DS, never forget DMS, never forget computer networks, DBMS, ATCs. These things become very important for all your technical round interviews and also for the GATE exam. Okay? I don't know how many of you are really serious about GATE. I'll be telling you that none of your seniors have cleared it. It simply means that you will be the first person. Okay, so if I take this 10 into consideration, this is what the support count I get. 2, 1, 1, 1, 1, 2, 2, 2, then again 2, then again 1, 1, all these things. We know very clearly, okay, we know very clearly that our support, the minimum support is nothing but equal to 2. Okay, is nothing but equal to 2. So wherever we have the support here, which is less than 2, okay, which is less than 2, what should be done? That's what we are going to see in the next thing. So you see this is nothing but 2 items support before filtering. So what we do now, since our support threshold or the support count is nothing but 2, what we do, we are going to remove the ones that have the support which is less than 2. Okay, we are going to remove the ones which are less than 2. That's what we are going to do now. So if we do that, this is what we end up with. How many are there? 1, 2, 3, 4, 5. How many were there? 10. How many end up with? Only 2. Sorry, only 5. Okay, only 5, which is nothing but 50% of it. Okay, this is nothing but a 2 item support table. We saw, see, this is 2 item support table. This is not a 2 item support table. This is before filtering, but this is single item support table. This is single item support table because clearly you can see that it has the minimum support of more than 2 or more than 2. Okay, then the next one what we get is with regard to this. Obviously, in the next step, what is the next step? The next step is to make sure that you take 3 at a time, 3 combinations at a time. There are total 5, 5C3. How many you get? Okay, you take 5C3 combinations now, which is basically among the 5 items, you are going to take 3 at a time. If you do that, how many you are supposed to get? What is 5C3? 6. Okay, so what are those 6 combinations? You got this ABC, ABD, ABE, BCD, BCE, BD. From where you need to get these values, you need to take that from the regular table, the transaction table only. From here itself you need to sort of make out that. Okay, how do you make out? You can see what is ABC. How many places do you have ABC? Only one, the first one, first transaction. In how many places do we have what is known as BCD? In how many places do we have something like an ABE? Like that, all 3 combinations together we need to figure out. You need to take the values from here, so please keep that in mind. Don't take it from the 1 support table or 2 support table and all. No, you have to take it from the original table itself. So if you do that, okay, if we sort of do that, see this, be careful with regard to it. If you take all the 3 into consideration, you got your ABC. I'll show that. Okay, ABC, because that's not written here. ABC, ABD, ABE. So I'll take that. Where is that? 1 second, I'll move the screen. So what are things that we have? Okay, so if you take that comparisons, the first one is with regard to ABC. How many times you have AB? I'll write the combination so that I'll not forget. Okay, ABC, then ABD, ABE. So this is nothing but ABD, then again ABE. So 3 combinations are over. Then the next 3 combinations, obviously BCD, BCE. So the next one is with regard to BCD, BCE. Okay. Then the next combination is with regard to BDE. Okay, so BDE. Any other combination, maybe CDE. Okay, probably it will be 0 itself. or else you can write, okay, C, D, E and all. What is the combinations you get? You get 0 itself. Okay. So what is the way you can figure out from this? What is the thing that we can see this? Okay. At this point, we are surviving items, or to make other patterns contain 3 items. If you logically work through all of the options, you will get like this. Okay. A, B, C, A, B, D, all these things that, we need to figure out what is to be done. Okay. So if you take from here, A, B, C is 1. Okay. A, B, D is also 1. B, C, D is also 1. Okay. Then A, D, E probably is 1. B, C, D 2. You get 2. What is the 2? This is very important. You get 2. B, C, D is coming here also. The combination of B, C, D is coming here also. Is there every other combinations what you are supposed to get? A, B, E, A, C, D, all those things, all the other combinations. Okay, all other combinations. What are the all other combinations? You got your A, C, D, A, D, E, B, except B, C, D, B, D, E, okay, C, D, E, all those things, C, D also coming only once. So all these things you can see very clearly that I can easily go here and write that except for B, C, D, where I get 2, all other places I get only 1. So except these, okay, except this, which is becoming very important, the support one of it, almost all you can easily sort of remove it. Why? Because the minimum support, please keep that in mind. That's very important. Why we are doing all this? Because minimum support is nothing but equal to 2. If that is equal to 2, which we are not supposed to get here, we are getting only in one places. So except this, except BCD, we are going to remove each and everything. So if we do that, okay, see that? Where is that? Once again. Yeah. If we do that, what is the only thing that is remaining? BCD is equal to 2. Now people may be thinking, what about 3 at a time, 4 at a time? Sorry, 4 at a time and all. Obviously 4 at a time, I don't think so there's any possible. Of course you can do. It's all taken out from here, but you can do. Okay. Just by looking at it, you can take A, B, C, D, 4 at a time. B, C, D, E. Okay, like that. Only 2 combinations only are there. A, B, C, D and B, C, D. The third one is only 3 items. So obviously you can get it also. Okay. So you get A, B, C, D as 1, B, C, D as also 1, which is less than support count. So at the end of it, okay, at the end of it, you can see very clearly. So what is the thing that you can see? Okay, the first one, the second one, the third one, like that, everything is taken out only except B, C, D. So the final list of patterns that have, 2 or more than 2. Okay, for 2 or more than 2 combinations, minimum support being 2 or more than 2 is what this. This is what you get. This is what you get. But majority of the times is we need to take the one which is having the maximum number of items with it. That's why it's called association. Now, see, they may be taken individually more than twice. Okay, they may be taken individually more than twice. But when you're talking about association, when you're talking about combinations with which the items are getting sold, then you need to see the ones that is having more than the maximum number of combinations. Okay, so what is that? That combination is nothing but BCD. How you can make out from it? You can make out from this seeing just by looking at it. You can see B is a constant factor. Okay, B is a constant factor in all the 3 transactions. C, you can see, is a constant factor in 2 transactions. D again is a constant in 2 transactions. When you take 2 into considerations, when you take all 3 into considerations, okay, these transactions may be increasing, okay, it may go up to a larger extent. Okay, taken only treat just for a simplistic point of view. BCD being the most used associate. So what is, if I am a retail owner, what I do? Okay, if I'm a retail store owner, what I do? Just by looking at that, I'll make sure I'll placing all my items like this. There's a B, whatever it may be bread, anything. Okay, there's a B, there's a C, and there's a D, all together like this. So a person who comes here, there's always a good probability that he's buying this, then he's buying this, and also there's buying his. I'll make sure that A and E, which are not that many, what do you call, common point of view, I'll keep it somewhere far. Okay, this becomes what is known as using A pro E principle. Okay, A pro E principle. What is A pro E principle? I told you very clearly. In simplest meaning, in simplest of terms, you are reducing what? You are not reducing the number of items. You are reducing the number of item sets. From A, B, C, D, E, you thought you came across to only B, C, D is very important to us. Like this, see, this is only for 3 transactions and of course 5 items. Like this, if there are 50 items and say maybe 300 transactions, then these sort of combinations to figure out the association combination becomes very important. Okay, very important to even understand and also sort of look out for it. Okay, this is the most important part that you have to keep in mind. Okay, at the end, what do you get? At the end, you can see very clearly that's been written that the combinations, the A pro E principle can be used to simplify the pattern generation process when mining patterns in data sets. Good. If the simple pattern is not supported, then a more complicated one with that of a simple pattern cannot be supported. Okay. Why we are doing all these things is to make sure that we get what is known as the most feasible combinations. Like that, you can do it for many things also. Okay, you can do it for many things. So one second, I'll just open that. Okay, so in the previous example also you would have seen all these combinations. Like this, we can do it for many things. Okay, many things we can do, and also to figure out various things of what they have done and all. So you can take one more example. Probably I think the time will be more for that. Okay, so we can take this example also. I think the time will be a little bit, will be taking more time, but anyway, we are going to take only up to the place where we need. Okay, so I'll just zoom it down. Yeah, now I think it's visible. Now, you see this? This is with regard to same old thing, but here we are changing it. What we are changing? We see we are changing what is known as the minimum support. See, I'm telling you the tracing part first. Then anyway, at the last, we are going to write the same thing in form of an algorithm. When I say algorithm, it is already there. Okay, you just have to look into it and sort of understand. But just by looking at algorithm, you will not understand. If you look into the tracing part of it, then when you see the algorithm, the reverse way, right? The reverse way becomes very easy. Okay, so if you sort of look into this, again, we have 5 transactions. The same old example only I've taken, the market basket analysis example. Okay, there are 5 items in this. And when I take all the individually, support count being only 3. I've taken support count being 3, not 2. Because more the support count, better the association analysis. Okay, so I've taken what is known as a 3 value. So when I do that, what is going to get? If when I take all individually, when I take one item sets, taking individually, what is the values I'm getting? I'm getting 4, 2, 4, 3, 4, 1. But my minimum support is only 3. Okay, my minimum support is only 3. You can see very clearly it is only 3, but it is clearly saying that you need to take, this is when you take individually, this is what you get. So wherever I have less than 3, where I have, this is one place Coke and another one is with regard to X. These things are very infrequent items. Is that correct? They're very infrequent. Just by looking at it, you know the values. Just by looking at the values, you know they are infrequent items. What I do next? What I'll do next? I'll do the most important part, which is to sort of mention that Coke and X are having a support count which is less than what I need. I need a support count of 3, but it is less than that. So what I do? What I do, obviously, I'll be taking it out. Okay, I'll be taking that out. So you can see very clearly one item sets. We are going to take out Coke. If I take out Coke from that, okay, if I going to take out Coke and X from it. So what is the thing that I get? I get the combinations like this. Please be careful here. These combinations, the combinations which you see here, okay, the combinations which you see here is after when I take out Coke and X right from the transactions. Okay, now I need to go for a 2 pair item sets. See, very clearly they have mentioned that there is no need for you to generate candidates invoking Coke and X because the minimum support is 3, but it is coming less than 3 for it. So I've taken it out. Okay, I've taken that out. What is my next job now? My next job is to figure out for a rule for this again. So if I go write a rule for this, what is the value I'm supposed to get? When I take 2 items at a time. Okay, when I take 2 items at a time, this is what I get. What are the values? You can see very clearly that bread and milk, 3. Well, not a problem. Beer, bread, only 2. Then again, bread and diaper, 3, not a problem. So there are 2 combinations which you get here, which can be easily taken out. What is that? Beer and bread combination, which is support count is less than 2, so less than 3. Beer and milk, which is again less than 3. Okay, but all other places, you got bread and milk, diaper and milk, beer and diaper, everything has a support count of 3. So that's not a problem to me. Okay, that's not a problem to me. So what is the next thing? Now, this is with regard to 2 pair item sets. Okay, 2 pair item sets. Okay, I have not taken any Coke or X into consideration here. So what is my next step? Next step is I'm going to take out the next important thing, which is what? I'm going to take out those bread and beer. Wherever I have only bread and beer, I'm going to take it out. So if that happens, what is the next thing? Next thing is I'm going to take it as with regard to triplets. So what is the triplets which I'm going to take? I'm going to take triplets, which basically means how many combinations are there. Okay, see, got 1, 2, 3, 4, 5, 6. In that, Coke and X are taken out. So 4, 4C3. When I take 3 at a time. Okay, 4C3. How many? You get only 4. What are those 4 combinations? This one. Beer, diaper, milk, beer, bread, diaper, milk, and of course, beer, bread, milk. Only these are the combinations that I get. Okay, so if I go for that, what is the number of counts I get? This is the number of count I get. Okay, this is the number of count I'm supposed to get. What is the count? The count being the fact that you got this entire thing, right? Count of 2, 2, 2, and 1. Okay, 2, 2, 2, 1. What is the next step? What's the next step? Okay, now I got the triplet counts also. The next thing is, of course, I've not done that. Okay, should have put that slide also. Okay, anyway, the next thing is to figure out which is the best thing among all this. Okay, there is no 4 combinations. Why? Because you need to go and check what is the maximum number of thing that you have here. This is nothing but 4. Okay, the maximum number of transactions that you have is per transaction is nothing but equal to 4. So if you take 4, everything will be 1, 1 only. Okay, if you take the maximum count as 4, the maximum transactions, all of thing will be coming as 1 only because the 4 itself is the maximum. If there have been 5, then we could have taken 4 because there's always a good probability that you may have one more. But here the maximum transaction itself is 4, so everything will be 4 itself. So among all these things, there is that last one. Yeah. So among all these things, which is having the best probability? Okay, which is having the best probability? So support count is 3, but we are getting all 2, 2, 2, 1 only. So for a support of 3, there's nothing like that. So for the best is with regard to 2 only. Okay, in that 2, what are the combinations that are best possible? The best possible combinations are here itself, the ones which represent 2, 2, 2. Okay, so what are those? Beer, diaper, milk you can keep together. Beer, bread, diaper you can keep together. Okay, and bread, diaper, milk you can keep together. Here also, based on that, you can clearly understand that beer is coming twice, bread is coming twice, and diaper is coming twice, milk is also coming twice. So what will be your problem now? Problem is to make sure that you keep all these 4 items together. If I keep those 4 items together except Coke and X, then I have a higher probability that people are buying that together. Okay, people are buying those items associated frequently. Okay, like this, we are going to take one more example also. Okay, we are going to take one probably tomorrow's class. Yeah, we are going to take one more example and we are going to look into it. Okay, I think that example will be even better than this, even bigger than this. Okay, so we are going to look into that and we are going to learn more about that, and later obviously we are going to write the which is the algorithm. Okay, this is the algorithm. I think it's taken right from the textbook itself. Okay, probably now you will be able to understand just by looking at it. It's taken and put it as a what do you call pick, right? So that's why it looks like this. I can't write all these symbols and all. Okay, so only check and put it as a pick and all. Okay, anyway it will be there. This is an example. So very important algorithm. You write this algorithm and then explain that 10 marks question. It's a 10 marks question easily. Okay, anyway we're going to take one more example because I want you to become very good with regard to it. Okay, especially be moving into the 7-sum aspect of it. Fine. Yeah. Now tomorrow's class we are going to take one more example and we are going to talk about it. Okay.